This is antimatter, more specifically an antiproton. It has the exact same mass as a proton but opposite charge, and when it comes in contact with a proton, they annihilate each other, releasing all of their mass as energy using the famous equation E equals mc squared. So how do we make antimatter? Again, by using E equals mc squared, but this time converting energy into matter. By smashing protons at nearly the speed of light into a block of iridium, we convert the energy in the proton into matter, more specifically pairs of protons and antiprotons, as shown in the animation at the start. Just a tiny amount of antimatter can produce huge amounts of energy, so you might be wondering, what if you could harness all that energy? Well, not so fast. Antimatter takes an enormous amount of energy to make, and the moment it comes into contact with normal matter, it annihilates, making it extremely difficult to store. So now that we know what antimatter is, how can we harness the power of antimatter to power rockets? One way of using antimatter to power rockets is to use antiproton propulsion, which involves annihilating a proton and an antiproton to produce thrust. When a proton and antiproton annihilate, on average, they produce 1.5 positively charged pions, 1.5 negatively charged pions, and 2 neutral pions. Because these are charged, we can use magnetic coils shaped similarly to current rocket nozzles to direct the stream of charged pions towards the exit, producing thrust. An antimatter rocket that uses this propulsion method will have much higher efficiency than current rockets. Using this method, we can achieve a specific impulse that is approximately 35,000 times better than current conventional rocket engines. Smashing antimatter to produce energy is easy enough, but storing it is a whole different matter. You have to cool it down to near absolute zero to reduce its movement, then use strong magnets to confine the antimatter inside a near perfect vacuum. This means that we need a lot of energy just to store the antimatter on the rocket, let alone use the rocket for producing energy, and we will likely need gigantic rockets to store the machinery needed. Also, we will need 100 million years just to produce a single gram of antimatter, which is way too slow to use antimatter as fuel. As you can see, we still have a lot of hurdles to overcome. We need to find smaller, lighter, and better ways to contain antimatter, and we need to find faster and more efficient ways to produce it. But if we manage to conquer these hurdles, it will revolutionize space travel and could start a new space age. We are innovating faster than ever before, and I am confident that in the near future, antimatter rockets will be a definite possibility. After all, who knows what the future could bring?